Today we will be covering multi-board system design with Cable Designer, and we will see how a simple cable can be designed using the Xpedition Enterprise tool suite. The whole process can be split into three main engineering tasks: library setup, logical definition of the cable, and the physical cable assembly. So let's get into the tools and begin with the library section. Two different libraries are involved in the design process: the EDM library and cable library. In the case of EDM library, a system connector needs to be specified on top of the regular EDM component, and the system connector contains some extra metadata that's utilized in the design process and the system design in particular. So the system connector metadata can now be added to the Samtech connector component in EDM library, and we'll use the connector wizard inside EDM library cockpit that will guide us through the whole process. So first of all, the system component is selected. It is defined as a cable connector in this case because the component has no PCB footprint. Next, we will specify the pin shape and the pin count. And finally, we will set up the mated connector. So the pin-to-pin mapping for the mated connector is defined in this dialog here. The cable library is another design domain library with different components that are managed relevant to the cable design process. And we'll take a look at some of these components. They include back shells, plugs, clips, and terminals, among other components. And connectors are managed in this library as well. However, different component metadata is involved compared with EDM library. So we'll open the same connector now in Xpedition Cable Library. So it'll have a different symbol in this library domain. The supply information can be the same, but in regards to the housing, it's about the terminals. So there are no relevant objects in the EDM library to match. Both libraries have EDX-based data synchronization for the connectors, so the part numbers and mated pairs can be synchronized. So once we have the library data ready, we can proceed with the logical design section of the process. And this work is accomplished in a tool called System Designer, where the board-to-board interconnectivity is managed. The tool is not solely for cable design, but this functionality is an integral part of it. In short, we must place the required cable connectors and specify the pin-to-pin interconnects represented by the wires between these connectors. So in the example, one of the boards in the design has a board connector, which is mated with a cable connector. And you may see the board connector here is located within the rectangular shape, and that shape represents a physical PCB in the system design. So a list of approved mated connectors for this board connector was specified in EDM library. So a suitable connector is selected from that list, and the connector pin manager is then used to place default symbols in the schematic. So we've placed our cable connector symbol here in the schematic, and we can rotate it if necessary, and then we can go ahead and use the mating command to mate this cable connector with the board connectors. And once the mating is complete, the pin-to-pin connections can be displayed. We can see by those dashed lines there, and this information is also taken from EDM library. We'll go take a look at the other end of the cable here. We have three chassis mount D-sub connectors, and the same process was used to place these connectors. The only difference is that they are not mated with any PCB board connectors. So we'll go ahead and place the cable connector symbols here, and then the interconnects for these four cable connectors now need to be drawn. So we'll go ahead and use the wire bus for this process in order to simplify the graphics and minimize the number of individual wires in the schematic. The wire bus corresponds with multiple wires, and the name of this wire bus can be generic. If required, the bus name can also be cable assembly specific. For instance, you can name it a multi-core part number. And the wires have a predefined bus content, or they can have a predefined bus content, as in this example. So the existing wires can simply be ripped from the predefined bus contents list that we see here. Once we've ripped these wires from the bus, we can go ahead and define any twisted pairs and or shields for the cable. And this is done by placing a special symbol type on top of the wire graphics in the schematic. This will create a multi-core wire structure in the cable assembly. So we're placing our twisted pair here over those two wires, and we'll go ahead and define a shield symbol for these wires in the cable. And as you can see, the graphics for these special components can be adjusted. The shield can also be connected to the connector and rotated if necessary. Once we've added our symbols here, we can adjust wire properties in the schematic if necessary. And these can help to drive specific wire implementation later on during the physical implementation of the cable. In this example, we will specify the wire color and material code. So we can add the wire color and material code properties to the wire in the schematic. And one of the last steps in the cable logic definition is selecting all the connectors and wires to be synchronized with the particular cable assembly design. So the 4 connectors and related wires are selected in the schematic and associated with the desired cable assembly. The System Manager is the tool inside System Designer that's used to accomplish this process. Once this is done, we can move on to the physical implementation of the cable using a tool called Xpedition Cable Designer. So first, we will import the logical data from System Designer. And once the data is synchronized, the list of connectors, wires, and related pin-to-pin connections will be available. Metadata specified in the system design is also available. In the example, you might remember that we specified the color and material group of one of the wires, and this information is now available within Cable Designer. Now we need to move on to drawing the bundles that represent the physical path for the wires of the cable. But first, we'll go ahead and clean up the cable diagram. So the bundle creation is relatively simple. In the example, the connector is selected, which is a dot in the diagram, and another connector or bundle is selected. The length of the bundles can be specified manually, or if the cable is designed in a 3D MCAD environment, these values can be updated automatically. A particular multi-core part number can also be assigned to the wires. And cable design is linked with the cable library. So the tool is dynamically verifying the design-specific multi-core structure against the library component structure. Different library search criteria can also be specified. And once the part number is assigned, the connector table is automatically updated with the library data. For instance, we can see cross-sectional area, color, and materials are updated. This library content can also be adjusted. The tool also automates certain tasks such as wire termination or multi-core part number assignment. So this can be accomplished both manually or automatically. Let's now update the bundle length in accordance with the 3D analysis done in the NCAD environment, in this case NX. The wiring harness data can be exchanged in a PXML format. After the file is imported, the bundles can be selected for update. As you can see, the other wiring harness objects can be synchronized as well. After the bundle length update is complete, the wire lengths need to be recalculated, and the wire table is updated automatically after recalculation. One of the last steps for the cable design would be adding an insulation tube. It's a standard operation Click on the bundle that needs a tube added. Select the part number so it's linked with the cable library, and finally go ahead and add the insulation tube. Then the length of the tube needs to be calculated and added to the component bill of materials. And the cable diagram and reports can now be extracted out of the database for production, with the database itself being managed in the Xpedition EDM environment. And with that, this now completes the cable design process in the Xpedition Enterprise flow.